This week, we're going to be using line plots to graph and analyze data. In the past, you've used this, it's called a pictograph, where the picture tells you the quantity for the different items you're tracking data on. Another way we have worked on data are bar graphs. In this case, it was about quiz scores. You can see the student's name, and they used a bar, and they went up to the value for each student to show you what they scored. All right, but we're going to be using line plots. All right, so for our first line plot, we're looking at people that ran a 100-meter sprint. The title says Times for 100-meter sprinters. The data below the line are the seconds that they ran, and every X you see represents a person who ran in the race. So our first question is, how many people ran in the 100-meter sprint? Well, the X's represent the people, so all I have to do is count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 sprinters or people ran in this race. It asks next, what time is an outlier? Or an outlier is when you have an X that is outside of like the majority of the data. And I think there needs to be 2 spaces or more that push them apart. Here we have 1 space, 2 space, 3 space. So the outlier will catch your eye because it's going to be far away from the majority of the data. So yes, this time we have one, and it is 11 seconds. Now when they ask you to analyze it, it means you have to make inferences that are reasonable. For example, I would not say this is a cat, and cats can't run as fast as people. That would be a silly inference. But what we could say is perhaps this person is older than the other runners, maybe somebody in their 70s. Or maybe this is one of the first times they've sprinted, and so they're new and maybe out of shape compared to the other runners. Or maybe they had a bad start and stumbled a bit. So there are different ways to describe the data, but when you do, you always want it to be reasonable and not something that's so far-fetched that it wouldn't make any sense based on the context of the data. All right, another question is used a lot is what time was most common? So that's when you go to the X's and you look for the tallest column. So this has the most X's above it. That means 10 and 4/10 seconds was the most common or most average time ran. Now it says what was the least amount of seconds ran. Well, a line plot will always have the smallest data on the left and count up to the highest data on the right, just like a regular number line. And so the least amount of seconds ran were 10 and 1/10 seconds. Now on Tuesday, I'm going to add different types of questions. So if you need to go back and watch some of the video again, you're more than welcome to do so. How many people ran 100 meters in 10 and 6/10 seconds, then in 10 and 1/10? So 10 and 6/10, right here, 1, 2, 3, 3 runners. And then the 10 and 1/10 is just 1 runner. We want to find out how many more people. So 2 more people for 10 and 6/10 seconds. All right. Now here's a bit more rigorous question. Curtis said more than half the people ran the 100 meters in less than 10 and 4/10 seconds. Well, here's 10 and 4/10 seconds. I'm looking for everyone who was less than that. 1, 2, 3, 4, 5, 6, 7, 8. 8 people. were less than 10 and 4/10 seconds. Now he said more than half the people. Well, we said in the beginning that 19 people were sprinting, and so it takes 11 more sprinters. So that is not half. 8 compared to 11 is less. So I would say no to Curtis. That's not true. More than half the people did not run 10 and 4/10 seconds, which is understandable because these are your winners, and you wouldn't have the entire group all crossing the finish line as fast as this group up here. That's not what normally happens. All right, so now I'm going to show you how to create a line plot. First thing you do is you find the smallest bit of data. So I search through. It looks like 2 and 2/4 is the smallest that I'm seeing. So the smallest data always comes first. And then the largest data looks like 3 and 2/4. So I'm going to include every single value until I get to 3 and 2/4, and then I'm going to stop. I plot each X and I try to make them the same size if I can. All right, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right. All right, so 5, 10, I should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, so 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, some people put large dots instead of X's. Those are fine. And you'll see that in today's assessment. So dots are just as fine as X's. All right, let's go ahead and practice these questions again. How many students are in Mr. Dixon's class? Again, the X represents students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Which number of hours worked was most common? I'm going to go to the tallest column, 1, 2, 3, 4, 5. So 3 and 1/4 hours was the most common time worked. Is there an outlier? Well, none of the data or X's have any spaces in between. So not all data has outliers. How many hours was the least worked to finish the project? The smallest amount is always in the beginning. So 2 and 2/4 hours was the least amount of time a student needed to finish. And then more complex questions. How many students took less than 3 hours to complete their project? Well, here's 3 hours. I want all of the X's that are for that. 1, 2, 3, 4. Okay, what is the difference between the longest amount of time worked and the least amount of time worked? Well, the longest time was 3 and 2/4. The greatest amount's always at the end. And the smallest amount, or least, is at the beginning. We subtract 3 minus 2 is 1. 2/4 minus 2/4 is nothing. So they have a difference between the longest time it took and the shortest of 1 hour. All right, I'm going to show you again how to set up a line plot. All right, I'm going to find the smallest amount of data. 4. Looks like it's 4. And then the greatest is 6. And we're counting in fours. So I make sure that I include every value from the smallest data to the largest data. All right, I'm gonna go ahead and start to put my X's. All right, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so now I should have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We got it all on there. All right, so let's look at some questions. What height is most common? So I'm going to go to the tallest columns. We actually have a tie. And so there can be more than one answer for this question. So 5 feet and 5 3/4 feet tall are both most common. How many students are in Miss Jackson's class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Is there an outlier? If so, what could it mean? Well, there is this gap in the data, and most of the data is here. So here's our outlier, and the outlier is 4 feet tall. And what does it mean? This student is short compared to his or her peers, which I can certainly relate to because I was always the shortest in my class all through school. All right, how many students are 6 feet tall? I go to my 6, 1, 2, 2 X's, or 2 students are above it. And some more rigorous questions. What is the difference between the tallest and shortest heights? Well, the tallest height is 6 feet, and the shortest is 4 feet. So the difference between the tallest student and the shortest student is 2 feet of height. How many students are taller than 5 feet? Well, there's 5 right there. So I want taller, and I'll count everything that comes after. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 kids are taller than 5 feet. All right. Now, when you are calculating today, be sure you're checking your numerators, and that when you can subtract, it's okay, but if you have to regroup, you do so. For example, this I can do because 2 minus 1 is possible. So 3 minus 1 is 2. 2 fourths minus 1 fourth is 1 fourth, and there's my difference. But when I look at this one, when I have fractions, I always want to make sure there's a fraction for each quantity. 0 minus 3 isn't possible, so this is where I have to regroup. I'm going to call 1 4/4 instead of 1 whole. They're equivalent. If I want to, I can add the 0/4. Either way, my regrouped amount is going to be 4/4. Then I bring down what I'm subtracting, and 4/4 minus 3/4 is 1/4. Good luck.